Hello everyone, so here are your notes for 1.5 angles. So let's go ahead and get started. The first thing that we need to do is we need to define what an angle is. It is made up of two rays with one common endpoint. Okay, we'll go ahead and we'll draw a picture of that, and I am going to zoom in here because we kind of have a lot to talk about for our first example. So let's go ahead and let's begin with a drawing of an angle first. So I'm going to go ahead and I'm going to start with an endpoint, and then from that endpoint, I'm going to draw a ray. And then from the same endpoint, because again, an angle is two rays with a common endpoint. So from that same endpoint, I'm going to go ahead and draw another ray. And now we have formed an angle. Now, let's go ahead and talk really quickly about the parts of the angle. The point, or that common endpoint that is shared between the two rays, this is called the vertex of the angle. And then the two rays make up the sides of the angle. So one side over here, and I have another side over here. Now let's quickly talk about how to name an angle. So I'm going to go and I'm going to add two more points, one on each ray. And let's go ahead and call the top point P. The vertex, let's call that L. And then last but not least, let's call this point on the ray V. So to name an angle, we have to make sure that when we name the order of the points, we need to trace out along the angle. Here's what I mean. I can go ahead and I can start with point P, and then I go to the vertex L, and then finish at V. So that's one name for this angle. It is going to be angle, and that symbol that I just drew stands for angle. Starting at P, then we went to L, and we finished at V. Of course, we can start with V instead. So we can call this angle V, L, P. Now, the only way that we cannot name this angle is starting with the vertex. Because here's the thing. If I start at L and I go to V, now we kind of have to jump across the opening of the angle to P. But the problem is that the angle does not connect points P and points V. And so we cannot just kind of start anywhere. We have to make sure that, again, when we name the angle, we need to trace along the actual angle itself. All right. Two areas that we need to go ahead and make a note of. First of all, the interior of the angle, or the inside of the angle. If we were to imagine that this angle were an open mouth, then the interior of the angle is going to be here in green. And then, of course, everything else on the outside is going to be considered the exterior. All right, now let's go and let's talk quickly about the different types of angles that we might see. The first kind of angle is an acute angle. An acute angle, the definition, is an angle that measures less than 90 degrees. All right, so let's go and let's draw a picture to demonstrate that. Now, the other thing I'm going to show you in the examples as we move along is the fact that there are kind of multiple ways to name an angle. So I'm going to show you another one right now. But first, let's go ahead and let's draw in our common endpoint. Draw the two rays from that endpoint. And I'm going to go ahead and I'm going to name this point B. Okay, now how do we know that this angle is an acute angle? Well, most likely it will be marked for us and they will tell us how much it measures. So in this case here, this angle measures 63 degrees. And because 63 is less than 90, this is how we know it's an acute angle. So angles like 81 degrees, 45 degrees, 32 degrees, anything less than 90 degrees is considered to be an acute angle. Now, as for the name of this angle, we can go ahead and use just the vertex to name this angle. The only reason why we can do this is because this vertex is not shared with other angles. But if we were to say add another ray from point B here, then we can no longer use angle B to name the angle, because the problem is if you say angle B, we're not going to know which angle you were talking about. All right, but let me go ahead and finish up the sentence. Angle B is an acute angle, and you can go ahead and use that symbol to abbreviate for angle. So angle B is an acute angle because it measures less than 90 degrees. All right, I'm going to go ahead and I'm going to skip right angle for a moment, and we are going to jump straight into an obtuse angle. Now, an obtuse angle is the exact opposite of an acute angle. So if an acute angle measures less than 90 degrees, then an obtuse angle is an angle that measures more than 90 degrees. All right, let's go and let's give ourselves an obtuse angle here in the picture. I'm going to draw an angle that's a little bit wider than the other ones we've been drawing. And another way to name the angle is to use the number on the interior of the angle. Now, the reason why we know that this number names the angle is because we also do not see the degree symbol. If we do see the degree symbol, then we know that this number represents the measure and not the name. But this angle here has no degree measure, so we can actually go ahead and we can call this angle, angle 2. And angle 2 has to measure more than 90 degrees. So, for example, an angle that measures 103 degrees is more than 90 degrees, therefore it is obtuse. Now, one thing I forgot to mention is that an obtuse angle is not only more than 90 degrees, it also has to be less than 180 degrees. This is due to the fact that if it is more than 180 degrees, then we're talking about something that goes past a straight line, and we're not going to touch anything like that in this particular chapter. But anyways, the definition of an obtuse angle is an angle that measures more than 90 degrees and less than 180 degrees. So finishing up this sentence, angle 2 is an obtuse angle because it measures more than 90 degrees and less than 180 degrees. All right. Right angles. So we talked about two different angles already. Acute angles that measure less than 90 degrees. Obtuse angles that measured more than 90 degrees and less than 180 degrees. So we need to now also consider an angle that measures exactly 90 degrees. And that is what a right angle is. So right angles look like a perfect corner, a perfect right corner when we go ahead and draw it. Now, the other thing to note is that all right angles are going to be marked with a square on the interior of the angle, like so. And when we see this mark, we are allowed to assume that this angle measures 90 degrees. All right, so let's go ahead and let's give our angle a name. And I am going to go back to using 3 points. Let's go ahead and let's call this angle WTR. So angle WTR is a right angle because it measures exactly 90 degrees. All right, one final angle type to talk about, and that is a straight angle. A straight angle is an angle that measures exactly 180 degrees. So here's what that actually looks like. It is actually going to look like a straight line. So I'm going to go ahead and I'm going to draw in a straight line like so. Let me go ahead and add 3 points here that we can use to name this angle. I'm going to go ahead and name it. Let's see here. T, R, and S. And the angle, the reason why it measures 180 degrees is because if we start here, if the ray starts here at RS, I can rotate that ray and then have it stop here at RT. And because of that rotation, that's the reason why this measure is 180 degrees. All right. So last vocabulary for this particular section, angle bisector. Now, bisector is a word that we have heard before. Again, as a reminder, this means to cut into two congruent parts. And what we're cutting this time is we are cutting an angle. In the previous sections, we were talking about cutting a segment, but now it's going to be an angle bisector. So an angle bisector is going to be a line or ray that cuts the angle into two congruent angles. Those would be the parts. The reason why we say two congruent parts is because sometimes we don't know exactly what it is that we're cutting, but because I know that an angle bisector has to cut angles, well, then we should end up with two more angles that are going to be congruent. So, in this picture here, let's go ahead and again, let's start with an angle. All right, giving these points names, let's go and let's call this B, C, and D. And then I'm going to go ahead and I am going to add a ray CE, and CE bisects angle BCD. So let's write that down. Ray CE bisects angle BCD. Now, because of this, I end up with two congruent angles. This is how we will mark congruent angles. One way to do it is to use arcs and then put tick marks on those arcs. So long as the number of tick marks match, this will mean that they are congruent. Another way to do it is instead of using the tick marks on the arcs, we can use the number of arcs. So if I have two arcs on angle BCE, I'm going to go ahead and need another two arcs on angle ECD because again, these two angles are congruent. So I can go ahead and write a statement that says exactly that. So thanks to the fact that ray CE bisects angle BCD, we now know that angle BCE will be congruent to angle ECD. And this will come handy a little bit later. Okay, so now that we have all of our definitions down, let's go ahead and let's take a look at a couple of examples. Example 1, it says to identify whether the angles below are acute, obtuse, right, or straight. And they do want us to write a complete sentence for each one. Okay, so taking a look at example A. Here we have an angle. Again, when I start naming the angle, I need to use one of the points on the sides. I cannot start with the vertex. So I can call this angle BRH or HRB. And I notice that angle BRH is 133 degrees. So because this is more than 90 degrees, here's what we can say. Angle BRH is an obtuse angle because it measures more than 90 degrees and less than 180 degrees. All right, taking a look at example B. Now, in example B, the angle PWM or MWP. We notice this box mark in the inside of the angle. And again, this box means that our angle is 90 degrees. And the only angle that measures exactly 90 degrees is a right angle. So angle PWM is a right angle because it measures exactly 90 degrees. All right, taking a look at example C here. Now, for example C, angle KVE or angle EVK, we notice that the measurement of the angle is 50 degrees. And because it's 50 degrees, that means that angle KVE measures less than 90 degrees, making it an acute angle. Alrighty, last but not least is example 1D here. Now, taking a look at this angle, technically the vertex would be here at point U. So beginning at the point on one of the sides of the angle, starting at F, to U to N, I can go ahead and call this angle FUN, or angle fun. And angle fun measures exactly 180 degrees. So that means that angle fun is a straight angle. Because it measures exactly 180 degrees. Okay, so there is one other item that we need to go ahead and cover in this section, and that is the angle addition postulate. This is very similar to the segment addition postulate, where if you have two parts of a segment, you can add them together to get the entire length of the whole segment. So this is very similar. So first, let's go ahead and let's complete this sentence. If point A is a common vertex, so this is what I was talking about earlier. It is possible that your vertex point is shared by multiple angles. So here, I technically have three angles. I have angle CAD. I also have angle DAB. And last but not least, I have the larger angle that makes up the other two, which is angle CAD. All right, so if this is the case, then here's what we have. We can go ahead and we can take angle CAD, or the measure of angle CAD. So writing it down like so, this is how we read it. We read it as the measure of angle CAD. And I'm going to go ahead, I'm going to add it together with the other part of the angle, which is angle, or the measure of angle DAB. And then together, this should equal to be my larger or my whole angle, which is going to be the measure of angle CAB. All right, so let's go ahead and let's use that angle addition postulate in an example. So for example 2, it says to write an equation that uses the names of the angles. Then they want us to substitute and solve for the indicated angle. All right, so in this particular picture here, they want us to solve for the measure of angle ACD. So that's actually this whole entire angle right here. I noticed that angle ACD is made up of two other angles. So because it is made up of two other angles, I can write an equation using the names of the other two angles. So I can take the measure of angle ACB and I can add it together with the measure of angle BCD. And this should be equal to the measure of my entire angle, which is the measure of angle ACD. And then once I have this equation, all I need to do now is substitute in. Measure angle ACB is 52 degrees, plus the measure of angle BCD is 97 degrees. And this is all equal to the measure of angle ACD, which is what we're trying to look for. 52 plus 97 is going to give me 149 degrees. And that is the measure of angle ACD. Okay, moving on to part B. They want us to solve for the measure of angle KLM. So angle KLM. Here's what we notice. Angle KLM is actually only a part of the larger angle or the whole angle, which is angle JLM. But even though this is a little bit different, we are still going to go ahead and use the exact same equation, the angle addition postulate. So the two parts that make up the larger angle, the two smaller angles that make up the larger angle, the first one is marked here in red. It is angle JLK. So the measure of angle JLK is going to get added to the other smaller angle, which is the measure of angle KLM. And this should be equal to the whole entire angle, which is marked with the green arc here. Notice how it begins with the side JL and it goes all the way over to the other side. That's how I know that this is the whole angle. So the whole angle again is the measure of angle JLM. And now again, we just substitute. The measure of angle JLK is going to be 81 degrees. And I'm going to add the measure of angle KLM. I don't know how much it is. This is the variable that we are solving for. And this is going to be equal to, well, the measure of angle JLM, we do know what that is. That's 121 degrees. All right, doing a little bit of algebra to finish solving, we're going to go and we're going to subtract 81 degrees on both sides of the equation. 81 minus 81 becomes 0. And what I'm left with is the measure of angle KLM. And this is equal to 40 degrees. All right, last problem for this section. So in this one, they want us to solve for the measure of angle DEG if ray EF is an angle bisector. All right, so first thing to notice, as always, is a key word. This word angle bisector means that we have cut the angle into two congruent angles. Okay, so ray EF, which is here, has split angle DEG into two equal congruent angles. One of those angles is marked here in red. It is angle DEF, and the other angle is marked here in green, which is FED. Just to help us remember that we are working with congruent angles, I'm going to go ahead and I'm going to add these tick marks to the arcs. Okay, so because these two angles are congruent, let me first go ahead and write a congruent statement. So angle DEF is congruent to angle FEG. And then from here, now we can substitute into an equation by replacing and substituting. 2x plus 10 represents DEF, and this will be equal to 4x minus 3, and that represents angle FEG. Now we need to go ahead and solve for x. I notice that I have my variables on two sides of the equation. So because they are on different sides of the equation, I can't just combine them and say that it makes 6x. Instead, I have to move them. And I'm going to move the smaller one, which is 2x. And the way I do that is the opposite operation, which is to subtract 2x on both sides. When I do that, this becomes 0. I'm left with 10 is equal to 2x minus 3. I'm going to go ahead and continue solving for x. I'm going to add 3 on both sides of the equation. 10 plus 3 is 13. And so we get that 2x is equal to 13. Last but not least, I want to go ahead and divide by 2 on both sides. And so what we get as our final answer is that x is equal to 13 halves. So you can leave it as a fraction, or we can convert this into a decimal, which is 6.5. Okay, but keep in mind that we are not technically done with this problem yet. We have to finish solving for the measure of angle DEG. So coming back to our algebraic expression earlier, the measure of angle DEG is actually equal to 2x plus 10. And then what we can do now is we can take our value for x and we can substitute it in. And then here's what we get. The measure of angle DEG is equal to 2 times 6.5 plus 10. All right, finishing this up, if you need a calculator, you can put that in. The measure of angle DEG is equal to 2 times 6.5 is 13 plus 10, which means that at the end of the day, the measure of angle DEG is equal to 23 degrees. And that right there is our final answer. Alrighty, so that is it for your notes for 1.5 angles. Thank you very much for watching.